This is the third lesson in Unit 1, and this lesson we are going to be solving equations and inequalities and also justifying what we're doing. So we're going to start off by reviewing some properties, and these properties are properties that you're already familiar with. You've already learned about them and how to use them. So let me just go through all of them. So the first one is the commutative property. Please notice that there is no N in the word commutative. The commutative property says that if A plus B, that's going to be equal to B plus A. So that works with addition and multiplication. It doesn't matter if you do 2 plus 3 or 3 plus 2, it is the same thing. You'll note that it does not work with subtraction or division. So if you have 5 minus 2, that is not the same thing as 2 minus 5. If you have 6 divided by 3, that is not the same thing as 3 divided by 6. So commutative property is good for addition and multiplication only. Okay, the next one is the associative property, and that says that if you are doing A plus B and you do that first and then you add C, that's going to give you exactly the same results as if you do B plus C first and then you add A. And this will work again for addition and multiplication. So again, it's kind of like it just doesn't matter how you group it. So this has to do with grouping. Okay, the addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. You do these every time you solve an equation. And so what this says is you do the same thing to both sides. And that's like the golden rule here. Both sides. Okay, and that's how we solve equations. So if you have A equals B, then if you add C and you add C, that's the same thing. You can subtract C from both sides, you can multiply by C on both sides, and that's how we solve things. So when we have an equation like x plus 5 equals 16, we subtract the same thing from both sides. And that's why it works. Okay, and so it's this right here is because the subtraction property of equality. I subtracted the same thing from both sides. You'll notice that on the division property of equality, you can divide the same thing on both sides, but C cannot be equal to 0. And that's because you can't divide by 0. So it works for everything except for 0. So that's just something we just don't do. And then the last property is the substitution property. Sometimes, depending on what is being demonstrated, it's also known as a transitive property. But it just says if A is equal to B and B is equal to C, then A has to be equal to C also. Okay? So if you have 2 plus 3 is equal to 4 plus 1 is equal to 5, then that means that 2 plus 3 has to be equal to 5. And so that's just an example of substitution. Now what we're going to do in these first couple examples is we're going to solve the equation that we have, but we're going to give a justification. So which of these properties are we using to do this step? Okay, and we do this, but we don't often write it down. And so on the first one, the first thing we're going to do is we're going to distribute this. Okay, so we're just going to say 6 minus 2n minus 10 equals 12. And so what we could do is we can say that this is, there's also, I should have put in distributive property. Distributive property. By the time you get this, I may have changed the paper. So distributive property, it just says if A times B plus C is equal to AB plus AC. And so that would be distributive property. Okay, and then to combine like terms, 6 minus 10, instead of writing 6 minus 10, I'm going to replace that with negative 4, which is of equal value. So when you replace something of equal value, that's a substitution property. Now when you do substitution property, do not just write sub. You can probably imagine why you can't just write sub. Okay, that's confusing, so you at least have to write that much of it. The next thing I'm going to do to solve this for n is I'm going to add 4. So if I add 4 to both sides, I am adding the same thing to both sides. So 2n equals 16, and that's the addition property of equality. Now the great thing about these properties right here is I will let you write A, P, O, E, S, P, O, E, M, P, O, E, and D, P, O, E. So you don't have to write the whole thing out. So this one's going to be A, P, O, E. And then the last thing I'm going to do is divide both sides by negative 2. So I'm doing the division property of equality, and I'm going to get divide by negative 2. So I'm going to get n is equal to negative 8. And so the justification is just what is allowing you to do that, what property is allowing you to do that. So on number 2, we are going to distribute again. So 1/3 of -6. So I don't want you to get a calculator. I just want you to think, if you have 6, what's a third? It's 2. So 1/3 of -6 is -2x. And 1/3 of 18 is 6. So when I give you fractions, most often I'm giving you very common fractions that you do not need a calculator for, so I don't want you using a calculator for that. So again, this is distributive property. And then the next thing I'm going to do is I'm going to subtract 6 from both sides. So that's the subtraction property of equality. So -2x equals -6. And then I'm going to divide both sides by -2. So that's a division property of equality. And that's going to be x is equal to -6 divided by -2 is +3. Now you don't have to do that on all of these problems, but I just wanted you to get, an idea of that we're using properties to do all of these. And so on this assignment, I'm only going to do a few selected problems. I'm not going to be doing all of them. So I'm going to do the ones that I've circled. The other ones, you can just look on the notes and see how to do them. You do not necessarily have to do them. If you feel like you understand it, you can not do them, but you just need to do the ones that I've circled. If you feel like you need more practice, that's what they're for. So number 3, we're going to distribute. So 1/4 b, 1/4 of -12. So it's a positive times a negative. 1/4 of 12 is 3. The next thing I'm going to do is I'm going to combine my like terms right there. So I'm going to have 1/4 b plus 12 equals 2. That's a substitution property because I substituted 12 instead of -3 plus 15. Then I'm going to subtract 12 from both sides. So I'm using a subtraction property of equality. 2 minus 12 is -10. And the last thing I'm going to do is I'm going to multiply by the reciprocal. I'm multiplying both sides by 4. So I'm going to have b is equal to -40. And then people want to know, do I have to write it in set notation? Yeah, let's write it in set notation. We need to practice that. Okay, I'm not going to do number 4 with you. It's very similar, except probably easier. Number 5, let's do that one. I'm going to erase what I have for number 3, though, so it's not in the way. Okay, number 5, I'm going to have, there's nothing to do on this first side, on the left-hand side. There's nothing to do there. I can't combine them, so I'm just going to keep moving. And I'm going to distribute over here. So -12 minus 4d. And then I need to get all the d's together on one side. So if I add 4d, it will go away from this side. And then, oh, hey, it's going away from that side. So I'm left with 4 equals -12. What did we learn about that in the last lesson? So this one is a no solution. So you're just going to write it like that. Okay, number 6 and 7, you should be able to work those out easily enough. There's going to be variables on both sides, so you're going to have to move the variables all to one side. So again, if you need to look at extra examples, they're in the notes. Number 8, 3x plus 3. If there's distribution to do, you often will do that first, just because it's really the best thing to do to simplify. And then 3 minus 5 is -2, so I've got 3x minus 2 equals 3x minus 2. So you might see what's going to happen right here, but if you don't, then subtract 3x from both sides, and you've got -2 equals -2. What did we learn about that? So we learned that means all real numbers, which means you can plug in any number you want for x, and it's going to be true. This is going to be a true statement. Number 9. On the right-hand side, I've just got some combining like terms to do. So I'm going to write -5r plus r is -4r plus 4. And then I need to get the r by itself, so I'm going to subtract 4 right there. So I have -6 equals -4r. And then I'm going to divide by -4. And so I'm going to have r is equal to now -6 divided by -4, negative divided by negative is positive. 6 over 4 is not reduced, so I'm going to reduce that. So 2 goes into 6 3 times, and 2 goes into 4 2 times. So this is my answer for number 9. Okay, on the next one, on the top part of this 11 and 12, it says find the value of x so the polygons have the same perimeter. So remember, perimeter is when you add all of the sides. So if I look at this pentagon on the left, I have 5 sides. I'm going to have 5 times x plus 3. Now you also could write x plus 3 plus x plus 3 plus x plus 3 and do that 5 times, but it's just easier to write it like this. That has to equal, because I want it to have the same perimeter as the trapezoid. So the trapezoid has 2 of those sides, and then a 2x minus 3 and a 2x plus 5. That's the equation I need to solve. Okay, so I'm going to solve that, and I'm sorry I can't write too small, you won't be able to see it, but I'm going to distribute first. I'm going to have 5x plus 15 equals, and then on the left side I'm going to distribute, so I'm going to have 2x plus 10 plus 2x minus 3 plus 2x plus 5. On the right hand side I need to combine my like terms. So I'm going to have 6x, and then my 10 minus 3 is 7 plus 5 is 12. Okay, now I'm down to an equation where I just have variables on both sides. So I'm going to get all of my variables on one side. So I'm going to subtract 5x. So I'm going to have, let's see, I'm going to come down here and write it. 15 equals x plus 12, and I'm going to subtract 12. 3 equals x. So the answer to number 11, x is equal to 3. That's what x has to be so that those two perimeters are the same. If x is anything else, then the perimeters will not be the same. Now number 12, it says what is the perimeter of each shape? So if x is equal to 3, the perimeter, so I'm going to have 3 plus 3, that's 6, 6, 6, 6, 6. So 5 times 6 is 30. And then the other one would have to be 30 as well. So that's how you check your work to make sure. So 3 plus 5, that would be 8 and 8. 2 times 3 is 6. Minus 3 is 3. And 2 times 3 is 6 plus 5 is 11. So 3 plus 11 plus 8 plus 8. Is that equal to 30? If it's not, then you did it wrong. Okay, now on 13 through 16, if you look at the extra video lesson that I did problems either just like this or very similar to this on the extra video lesson I did for 1.2, so I'm not going to do those again. And we're just going to skip down to this next section. So you're going to write your solutions in interval notation for these inequalities. So I think I'm just going to do a couple of these, and I think I'm going to just do 18 and 20. They look the hardest. You can look on the notes for number 17 and 19, but I just want to make this video not too long. So number 18, I'm going to distribute first. So negative 10v plus 10 plus 7v is greater than or equal to negative 2. So I just simplified that. The next thing I'm going to do is combine my like terms. So negative 10v plus 7v. And then plus 10 is greater than or equal to negative 2. And then I'm going to subtract 10. So I'm going to have negative 3v is greater than or equal to negative 2 minus 10 is negative 12. Now you're not flipping a sign here because you're just subtracting. You didn't multiply or divide both sides by negative. But the next step, we're going to divide by negative 3. And now I'm dividing both sides by a negative. So now I am going to flip my sign. Negative 12 divided by negative 3 is 4. So when I graph this, I'm going to have a 4 right here. You need to have something on either side to show context. Since it has an equal sign, I'm going to have a filled in dot. And b is less than, it's going to be that way. So those are my solutions. Now it says write in interval notation. So my interval notation will be v is an element of, my interval starts at negative infinity and it ends at 4, and that's inclusive. So I'm going to have a square bracket on that one. Okay, the last one I'm going to do, number 20. I'm going to start by simplifying on the left-hand side. And so we're going to have 6. Negative 2 times 5n is minus 10n, and negative 2 times 5 is negative 10, less than or equal to 12 minus 10n. On my left, I'm going to simplify those. So 6 minus 10 is negative 4, and then 12 minus 10n. And then I need to get my n's all together, so I'm going to add 10n. So what I have is I have negative 4 is less than or equal to 12. Okay, that's weird because there's no variables. So what you do is you look at that and you say, okay, is that true? Is negative 4 less than or equal to 12? Yes. Okay, is it always true? Yes, no matter what n is. It's always true. And so that means that you can have a graph, but every single number on it is going to be a solution. And so that means all real numbers. And so how do you write that as an interval? If you go back and look at the end of lesson 1.2, I had a graph or a chart that showed you how to write all of the things. And so remember that the way you write interval notation is you're going to write n is an element of negative infinity to infinity, and that's all real numbers. So that would be your answer for that. Okay, so next you're going to go and do your homework. You can go back and do the additional examples that I didn't do, so 17 and 19. Make sure you know how to do those right there. On the previous page, the problems that I didn't do, you want to go through and do those. Make sure that you're good on those. And if you feel like you need to do them, you can. If you feel like you understand what we did, then you're fine to just start with your homework. But if you're doing your homework and you see a problem, you're like, oh, I'm not sure how to do that, go back and look and see if there's an example in the notes, because most likely there is. And so you may need to look back at that. When you're done with your homework, check it with the answer key, and then you will submit it.